All right, so let's go over this. So our warm-up. All I wanted you to do was make a list of perfect squares. So how far can you go? So what are your perfect squares? What are perfect squares? First of all, what is a perfect square? They're numbers that are square. Let's try to go in order. What's the first perfect square? Right? Just think 1 to the second power, 2. The square just means to the second power, right? So think of 1 to the second power, 2 to the second power, 3 squared, 4 squared, 5 squared, 6 squared, and there's your list. That's all you have to do. So my list of perfect squares is 1 squared is 1. 2 squared is 4. 3 squared is 9. And how far can you go without having to use a calculator? Right? What's 4 squared? Let's see how far we can go. Mister, you're getting crooked. Okay, I'll straighten this out. So our perfect squares are 1, and then 2 squared is 4, 3 squared is 9, 4 squared is 16. Okay, what's the next one? 25, good. Next. 6 squared is, close, 36. 7 squared, good, 49. 8 squared, 64. 9 squared, you guys should know these, 81. 10 squared, that's the easy one. What's 10 squared? 100, very good. 11 squared, this is where people start tripping up now. What's 11 squared? 120, 1 what? 100 what? Hold on, I don't know if I got that. 100 what?
21.
Yes, 121. 12 squared? 144. Now, this is where a lot of people stop. They're like, all right, 12 squared. Back in elementary school, back in 3rd or 4th grade when I learned my times tables, that was the last one in the corner. 12 times 12. I don't know 13 times 13. So what is 13 squared? Do you guys, anyone know? You should know. Your Algebra 1 teacher should have told you to memorize your perfect squares up to 25, but if you at least go up to 15 or 16, that would be good. 169, very good. What's 14 squared? $196, very good. It's just a 9 to 6, switch places. What's 15 squared? Yeah, Edgar's smart. Why are you shocked? Yes, 15 squared is 225. Very good. 16 squared. See how far we can go. Now, you don't have to. You can live life without memorizing these. It's just nice to have these in your brain, and when you see them, you recognize them as perfect squares, especially when you're factoring, right? Or when you're doing stuff with radicals. What's 16 squared? Anybody? Oh, I think we got to the point where everyone's stuck. 16 squared, 15 squared is 225. 16 squared is 2. Come on, guys. Can't do this on my own. This is you. Is this on? Am I on mute? Let me check. No, I'm not on mute. Come on, guys. What's 16 squared? 16 to the second power. 256. Thank you. And we can stop there. If you want to go 17 squared, anyone want to just do that before we go to the next one? 289. Very good. And then 18, 19, 20. Do you guys know what the square root of 441 is? What's the square root of 441? Just really quick. What squared gives you 441?
21.
Very good. Very good. Yes. All right. So those are your perfect squares. Those are your perfect squares. Okay. And I think some of you, maybe you didn't get, I totally didn't do it on a calculator. It's okay. There's a list. There's some numbers that when you have perfect squares, you should recognize those as perfect squares. Okay. Those should look familiar. Perfect cubes. I don't know if any of you have done that before. What are perfect cubes? Well, let's do the same thing. Let's get 1 to the third power. Cube just means to the third power. Then get 2 to the third power, and that's a cube. 3 to the third power. And so what's 1 to the third power? Duh, it's 1. Ooh, someone said 3. It's okay. What's 2 to the third power? 2 times 2 times 2. 8. Very good. Not 6. 2 to the third power is not 6. It's 8. What's 3 to the third power? 3 times 3 times 3. 27. What's 4 to the third power? 4 times 4 times 4. 64. There you go. These are all cubes, perfect cubes, numbers to the third power. Now, you don't have to memorize these, but you should recognize them. We'll have this little list. You should have this list with you in your notes. What's 5 to the third power? 5 times 5 times 5. Well, 5 times 5 is 25, and then 25 times 5 is 125. Good job. Let's do a couple more. What's 6 to the third power? 6 times 6 times 6. 216. Very good. And what's 7 to the third power? Let's go up to 8. 7 times 7 times 7. So 7 to the third power is 343. Good job. And let's stop at 8. What's 8 to the third power? Last one. 8 times 8 times 8. 512. Good job. Good job. Edgar, thank you for participating. Thank you. We have usually the same people participating. Edgar's joining the crowd today, and I appreciate that. I want everyone to participate, but those of you that participate in the chat, give yourself a hand. Give yourself a hand. Good job. So these are numbers you should recognize as perfect cubes. Okay? Numbers to the third power. If you want to go beyond 8, you can. But again, some people said, hey, mister, I use a calculator. I'm not against using calculators. You know, there's a lot of teachers that are against using calculators. I'm not against calculators. Again, when we graphed, what did we do? We used a graphing calculator to graph because we don't want to. We are in the day and age where we don't have to graph polynomials by hand. We have technology, and calculators have been around forever, right? And so why not use those? But it's good just to know, just to have an idea of some numbers and just recognize them. 27, 64, 125, 216. Your brain should go, oh, that's a perfect cube, isn't it? And you can check with your calculator. That's fine. But it's just a good idea to have these, on hand in your brain. And perfect fourths. What are some perfect fourths? Well, 1 to the fourth power is 1. 2 to the fourth power is 2 times 2 times 2 times 2, which is 16. Good job. 3 to the fourth power is 3 times 3 times 3 times 3, which is 81. Right? 4 to the fourth power is 4 times 4 times 4 times 4, which is 256. Good job. And then let's just stop at 5. 5 to the fourth power is 5 times 5 times 5 times 5, which is 625. Which, if you think about it, it's a fourth is just the squares squared. It's basically you're getting all of these and you're squaring it. 4 squared, 1 squared is 1. 4 squared is 16. 9 squared is 81. 16 squared is 256. 25 squared is 625. So you're squaring the square. So to get fourths, you're basically squaring the squares, aren't you? So you can get this list that's already squared and then square each one to get the fourth. Oh, I didn't think of that, mister. Didn't think of that. Mister, you did it again. What did I do? My mind is blown. So we have new notes. Did all of you go to, actually, I'm not recording, am I? Am I? Oh, yes, I am. Yes, I am. Thought I wasn't recording. So we have new notes. And just as a reminder, I do this every time. And if you're like, mister, you do this all the time, I'm sorry. But you go to Schoology, click on courses, go to our course, period 13, go to week 12. We go here, you will see yesterday's video link is there. Right, and today's video link will be put there later today. I'm going to be better at putting them up now that they can upload. Then we have simplifying radicals notes, and then we have the notes solutions, and then we have the homework. Homework is due Friday. Okay, we should be able to finish that up by Friday. So radical notes, again, This is not an assignment. It says due Tuesday, April 6th. The only reason that says that it's due, I'm saying this again for the millionth time. It's okay. Some of you need to hear it a million times. I put this as an assignment because it's the only way you can work with Kami with it, right? So when you go here on your Google Chrome browser next to view, you should see open with Kami. And a lot of you like to take your notes in Kami, and you can open it that way. Somebody asked me an interesting question, and no one's asked me this all year, and I never even thought about it. But someone asked me, Mister, how do you do your notes? Because Kami, I'm writing with my finger. How do you do your notes? Like how do you do this? So here's the notes, right, that I opened up. Well, I use a note application. I'm using my iPad, right? And those of you that had me last year, you saw me. It's on my iPad, and it's called Good Notes. It's an app called Good Notes. Now, that costs money, but basically there's a whole bunch of note apps that do this. You can load in any PDF into the app, and then you can zoom in, and with your finger or with the stylus, or I have the Apple Pencil, you can use an Apple Pencil. There's a little toolbar at the top that you can't see because I'm presenting it to you, so it blocks all that. But there's a little toolbar up here. I can change different tabs to go to different PDFs. I can change the color, and then I just use my Apple Pencil to write on. I can use the shape thingy, and it turns it into a shape. So yeah, there are different apps. We were looking that up last period, and we were looking up notes. So you just go to your app store, look up notes, and I'm pretty sure. I mean, they have the same thing on if you don't have an iPad, if you have a Android device, it's the same thing. These apps are made for Android. So there's Notability, there's Good Notes, that's the one I have. There's Quick Notes. A lot of these are free, and then if you want to have advanced features, it costs a little more. But most of them, look for a free one, and then you can just write. I love this. All my meetings and stuff, I take my notes on my iPad. I don't use paper anymore, because it just makes my life so much easier. I think when you go to college, I would invest in a nice iPad or a nice Android device where you have an actual pencil or a nice stylus, and take notes this way, because it's look at this one, AnyPlan. See that it has tabs and stuff, and it just looks like a notebook you have, but it's in your. So if you were wondering, because someone finally asked first period, what the heck's going on, Mister? How do you do that? It's just an app where you can load PDFs, which is nice. You can load any PDF into the app, and then you can write on it, and it saves it. And then you can save it in tabs, you can save it in folders, you can save it. Some of them are designed like notebooks where it has dividers and stuff. So that's how I can do it. So let me give you a minute to go ahead and get your notes out. Let's start taking these notes. Oh yes, somebody asked, Mister, I saw what is Note Solutions, Mister? So you go over here, back to, if you look here, there's the notes, and then under it is the Note Solutions. So if you miss any notes, you can just click Note Solutions, and there's all the problems worked out and everything there. Not exactly what we do in class, because I'm writing on my pencil. This is just pre-written note solutions, so that might help. And then there's the homework. So yeah, note solutions are there. That's not an assignment, because you can just open it up and look at it. So I'll give you a minute to either print it out, open it up in a new tab, open it up in Kami, however you do your notes. I'll give you 1 minute. And then we'll start taking our new notes. Alrighty, time is up. You should have your notes by now. So let's go over these. So if you look here, the top of the notes is your warm-up. Put your list of perfect squares, perfect cubes, and perfect fourths. So you can put it right there, exactly what we did in our warm-up. Just copy them over into there. Okay, I'm not going to do that now because we have them over here. Where is it? There it is. We have them here. You just copy those over to that list on the notes. Okay? And so now, what's a radical? What's a radical? When you take a square root, okay, back in when did you learn square roots? You know, I'm still not used to this. Asking a question and hearing silence. I at least have a couple of kids. Was it 7th? Yeah, I think it's like 7th grade, right? So you learned a square root back in 7th grade. So like the square root of 16. And then you guys knew square roots as, some of you, I was asking my my geometry students, and I'm like, what's a square root? Tell me what a square root, because we're doing Pythagorean theorem with them. And so I went over square roots, and they're like, oh, it means divide by 2. Oh, no, it does not mean divide by 2. And I know that's one of the first things you thought when you first saw square roots. And then someone said, oh, it just means divide. Divide by what? Divide by itself. I'm like, well, like square root of 16, if I divide 16 by itself, that's 1, and the answer is not 1. And if I divide by 2, that gives me 8, and the answer is not 8. Why is the answer 4? And then someone said, oh, because square root means what number times itself gives you 16. And that's perfectly fine. That's a perfectly fine definition for square root, right? Square root. This is what we learned in middle school, 7th grade. Square root, what number times itself gives us that number. It's kind of a long definition, right? But that's basically what we're doing. So I'm going to show you, and you should have, and if you had me for Algebra 1, or if you had Algebra 1, you should have learned the actual way that a radical works. And a square root, the reason we call it a square root is because it is the opposite. It is the inverse of squaring a number, right? So if I get 4 and I square it, I multiply it to itself. When I get 16 and I square root it, I try to figure out what I had to multiply to itself to get that. It undoes a squaring. So it basically, when I do this, I'm saying the square root of 4 squared, because I'm rewriting 16 as 4 squared. And the reason I'm doing that is because this square root and the squared cancel out, and my answer is 4. Okay, and we also have another answer. We can also say, oh, negative 4 squared also gives me 16. And that's why when these cancel out, we also get negative 4. That's why we get 2 answers. Okay, but we're looking at roots as the inverse of raising it to a power. Okay, so we have a square root, we have a cube root, we have a fourth root. We have all kinds of roots, not just the square root. So that's what we're going to be looking at. So we're going to look at the nth root of a real number, right? Square root, cube root, fourth root, fifth root. When I say n, there should be a little number here. I know in the square root, if you look here, you're like, mister, there's no number right here. I've never seen a number there. Actually, there is. There's actually a little 2 right there for the square root. We just don't write it because that's our first and basic root that we use. And so when you don't see a number there, it's a square root. But there is a little 2 there. And so that number that you see in the check part of the radical, that is called your, does anyone know? What is that called? That little number inside the check mark of the square root. Yes, I am recording this. Some of you are saying right now, mister, radicals were so easy. Square roots were so easy. You're making it more complicated. No, I'm not. I'm explaining the parts of a radical. So what's that little number that you see in there? That you don't see that should go right there? Does anyone know the name of that? Nobody knows? That's called your index. It's called your index. And that tells you what root. It tells you what kind of root you have. Right? And if you don't see a number there, it's a 2. It's your square root. It's your basic one. And then that little sign, that's called the radical sign. And the stuff that's inside the radical is called the radicand. And then right here you see at the bottom, if there is no index, then it is assumed that it is 2. Okay? Any questions? Any questions? That little number in the check mark part of the radical sign is called the index. That tells you what kind of root you have. What kind of root you have. The actual sign is called the radical sign, and the stuff that's inside the radical is called the radicand. And if you have no index, if the number here is not there, it is a 2. It's a square root. Any questions? This should all be reviewed, but if it's not, It's okay to ask. It's okay to ask for clarification or tell me you don't understand what I'm talking about. Okay. So I would like you to try this first row. Oh, can I zoom in on what? Hold on. Somebody asked me to zoom in. I know this is kind of blurry, and I apologize. I upgraded my internet to have a gig of internet. So I would have as much bandwidth as possible to send to you guys. But I don't know, Zoom doesn't always work the best. So yeah, if it's blurry, I apologize. I try to zoom in as much as possible. Again, the videos are a lot clearer if you want to watch later. Okay, let me know when you're ready so we can go down and try those. Because what I want you to do, okay, if you're still copying, that's fine. But what I like you to do is I like you to try the square roots, then try the cube roots, and then test yourself and see if you can do the fourth roots. Okay, so let me zoom in on this and then try to do the problems below that, please. I'll give you 7 minutes. Nope, that's not 7 minutes. Okay, so do the practice problems below. Can you find the square roots of those numbers? Can you find the cube roots of those numbers? And can you find the fourth roots? Actually, let me do the first one of each. So square root of 16, here's how I want you to show it. Square root of 16 means the square root of, since this is a square root, I need to write the insides as squares. So I'm going to put 4 squared so I can know what to cancel. And that's how I get an answer of 4. Okay. If I look here, I have a cube root of 8. Well, 8 can be rewritten. Since this is a cube root, I got to rewrite it as a cube. So 8 is 2 cubed. So the cube root and the cube cancel out. And that's how I get 2. And then down here, I have the fourth root of 1. Well, 1 can be rewritten as 1 to the fourth, right? Because I want to rewrite my insides, my radicand, as something to the fourth power, because that means the fourth root and the fourth power cancel, and that's how I get an answer of 1. Okay. So there's the first ones. I want you to try the next ones in each row. All right, time is up. Time is up. So let's go over this. Let's do the square roots first. And yes, could you just pop these into your calculator and get an answer? The answer is yes. I can just put square root of 121 in my calculator and get 11, right? But I want you to look at it like this. 121 is the same thing as 11 to the second power. The second power and the radical cancel out. And the reason I want a second power is because I want this power to match the index, because that's what it cancels out. The power and the index cancel each other out. So if I have a square root, it cancels out a square. If I have a cube root, it cancels out a third power, a cube. If I have a fourth root, it cancels out a fourth power. Is that clear? So that's why I do that. So once they cancel out, I got rid of my radical sign, and that's how I get 11. Okay, I want you to look at it like that. Yes, you can use your calculator. I did tell you earlier, yes, you can. But I want you to see it as this, because when we start simplifying these radicals, which I think we've done before, you can see why we're canceling out certain pieces. Okay, so what's 289? How can I rewrite 289 as something to the second power? Because I want it to the second power, so it cancels out that square root. Anyone know? What to the second power gives me 289? $17. Very good. So that's like same thing as saying 17 squared. And then the squared and the square root cancel out. And that's how we get 17. Okay. And then the last one's a fraction. And some of you looked at that and go, oh, I hate fractions. Yuck. Okay. Don't freak out. When you have a fraction inside a radical, you can separate them. You can give a radical to the numerator and then a radical to the denominator. And then we can see, oh, square root of 4 is just a square root of 2 squared. Square root of 25 is a square root of 5 squared. That cancels with that. That cancels with that. And so I have 2 in the numerator, 5 in the denominator. Mister, yeah, you're doing all these extra steps. Square root of 4 is 2. Square root of 25 is 5. I'm done. I didn't do any of this, mister. Oh, that's okay. That's fine. But I want you to understand that the root and the power are what cancel out to get you that number, right? That's what's going on. That's how you're figuring this stuff out. Okay, everyone good? Everyone good on the square roots? Anyone need me to zoom in on any of them? Explain any of them? Hello, is this thing on? No one, because no one's responding. No one's responding. Your silence is making me think you're getting this, but that is not necessarily what's going on. So please let me know. Show me a thumbs up or something at least. Give me something, guys. Wake up. Okay, there we go. There's a couple of thumbs up. There's a check mark. There's 2 check marks. Okay, good, good. I just want to see, just want to make sure you're out there. Right? So 6 of you get this. The rest of you, what's going on? All right. Let's look at the cube roots. So we did the first one, right? So cube root, you look at your index, you see the index is 3. So I want to get the insides, the radicand, I want to get the insides to a power of 3 so it cancels it out. So I'm left with a number, right? So then I look at 343 and I'm thinking, was that in our list? Let's look at our list. Yeah, that was in our list right here. That was 7 to the 3rd power. So we can go over here and we can say, okay, cube root of 7 to the 3rd power, because 343 is 7 to the 3rd power. The 3rd root cancels out with the 3rd power, and that's how we get 7. Yeah. Move on to the next one. Ooh, we have a negative. Some of you are saying, mister, if you have a negative inside a radical, it's no real solution. And I would agree with you. Only if this was even. Right? If that's an even number, that means I have a 2nd power or a 4th power or a 6th power, right? And if I have an even number, that means I have an even number of negatives, right? Because that's going to cancel out with the power. So if I have a 4th power, that means I have 4 negatives. So I'm multiplying the number to itself 4 times. And so that always turns positive, doesn't it? But an even number means, an odd number means I have an extra negative. 2 of them will cancel each other out and I have an extra negative. So this is not true for odd. If I have an odd index, I can have a negative inside. What do you mean, mister? Well, let's think about it. What's negative 5 to the 3rd power? What's negative 5 to the 3rd power? Isn't that negative 5 times negative 5 times negative 5? Right? And then these 2 negatives are going to cancel out. So that's going to give me positive 25. But that negative over here with the last negative 5 is not going to cancel out. And so 25 times negative 5 is negative 125. So if I have an odd power or an odd index, an odd root, I can have negatives. It's possible. Because only 2 negatives make a positive. If I have an odd one, if I have an extra negative that's odd, it's not going to cancel out with anything. It'll stay there. So I can rewrite this as negative 5 to the 3rd power. Right? Negative 5 to the 3rd power, square root, and then cube root. And that cube root cancels out with that 3rd power, and so my answer is negative 5. Does that make sense? Does that make sense? You can have negatives inside the radical if you have an odd index. All right, we're going to stop there. We will continue with this fraction. It is negative and it is a fraction, 3rd root, and then we'll do the 4th roots, and then we'll fill out this little table tomorrow. Okay? If you have any questions, let me know. I will put this video up today, so it will be up, and you'll see the link in Schoology later today. But that's it for today. You can start the homework if you want to. We will continue tomorrow. Have a great day, everyone. I will see you all tomorrow, and take care.